Thank you very much, Ephraim, for this opportunity. Again, everyone, welcome you to today's webinar series on product engineering. We were here a couple of months ago with a series on building tech tailored for Africa. Generally, we were speaking about building solutions that fit our ecosystem, fit the African people, that address our local problems. And this is a complementary series. We shall have 4 sessions before the year ends on product engineering. And we've come across a lot of products out here, but how are they engineered? So I'm going to start the intro for the series for the day and cover on some few concepts, but feel free to ask questions, type them in the chat so that as we even progress, we can actually answer some of the questions. And going to the main thing of the day, product engineering. Of course, we've had a lot of concepts, software engineering, software development, and today we are here with the product engineering. So ideally, it's a process of applying engineering principles to the entire life cycle of a product. So everything you interact with is a product. The messaging platforms we use are products. E-commerce platforms we use to purchase goods online are products. And the process of applying engineering principles to the entire life cycle of creating these products is what we refer to as product engineering. So it's a process that is there from the conception of your idea to the end of life, which is the actual product. So it goes beyond just developing a product. It focuses on its quality, costs, performance, usability, reliability, and serviceability. So talking about quality, what are the standards that your product is running at? Talking of costs, what are the cost implications of the process or the engineering cycles that you're using in developing these products? Performance, what are your performance metrics? How do you check my product is working or this solution is good? Is it performing well? Usability, how is the solution or the product that you have engineered usable? Is it user-centered? Have you designed it with the users in your context? And then reliability, is it a reliable product? And serviceability, is it offering services to the people? So this is what we will be checking at today on the entire life cycle and ensuring that we build products that are quality, cost-effective, performance, they are usable, they are reliable, and offer the intended service. So as an engineer who is doing the product engineering, what are the roles that these people are supposed to be doing? The role majorly for product engineer will be to design, to develop, to test, and to maintain both the hardware and software components. And remember, even as we speak of products here, yes, we might be speaking of products from a software perspective, but also products can be hardware. Any product that you see out there, be it a tech product or any other product, there are some engineering principles that are applied. And these engineering principles normally cut across, and we apply the same principles specifically in software. So moving on next, why does product engineering matter? Most of the products begin with an idea. Mostly someone sits down and has an idea. Oh, I would like to create a platform where I can message my friend. Yep, I would like to create a platform where I can post something and my friends can see it and they can react to it. I would like to create a platform where people can share short videos in form of statuses. That's an idea. So product engineering matters because it transforms your idea into a tangible, high quality and market ready product. Most of us here might be developers, and most of us might also have ideas, but we've never realized our ideas to a certain, to become a product. And there are some engineering principles that you need to apply. And that's the life cycle that we're going to discuss today before you get to build your product. So the process itself, the engineering process itself helps in enhancing your quality of the product that you're going to build. It speeds up time to market because most of the time you might begin a project and it never ends and you are stuck in a sort of a loop. It optimizes your costs and it fosters innovation. So this is why we are discussing this today. I like starting at why we are doing it so that we can kind of get and relate to why are we discussing this, why are we converging here today and talking about this entire life cycle. So mostly the product engineering life cycle itself will have a number of steps. And disclaimer here, the life cycle might vary from organization to organization. Some companies have their own style, but I came up with just a brief or as a general overview of how the product engineering life cycle looks like. It's not cast to stone that it must look like this, but these are most of the concepts that will appear in any life cycle. Number one, concept development. This is the ideation, market research, and feasibility studies. Mostly, if you know of the software development life cycle, of course, you start with the requirement phase before you move to the design phase, and then you move to the implementation, which is the actual development of your product, and then you kind of deploy and test your product. But in the product engineering life cycle today, we are going to go deeper and kind of approach some of these phases in a different way. And number one, concept development. Of course, we say that the life cycle itself, or engineering, the product engineering process is your idea to a product. So mostly, number one will always have to do something, to be something to do with the idea. That is ideation, brainstorming, research, feasibility studies. Is it feasible? Am I addressing the right problem here? And then number two, design. Of course, you have to create detailed specifications, models, and prototypes. So design can be as deep or as detailed as you'd like, but there are some things that you cannot do without some design aspects. And then number three, we have development. That is building and integrating software and hardware components. That is actually where the process itself happens. And then after you build something, you have to test and validate, evaluating performance, reliability, and security. And then you have to launch your product, release the product to the market, and gather feedback. And then, of course, from there, it's an iterative process. So you have to maintain and support to provide ongoing updates, bug fixes, and feature enhancements. So that is ideally what will happen in any life cycle, from development of your concept to actual launch of your product. And next on, I would like us to go deeper in some concepts. I'm going to take every single cycle step and kind of try to marry it to some other methodologies that we have in software development, because we live in a modern era where we don't do things traditionally. We have to apply some methodologies that have come up. And we will start with the concept development. So as with product design, so product engineering begins with brainstorming. So anything to do with brainstorming, that's where ideation comes in, and conceptualization of product ideas. Ideas are the big thing there. While engineers typically don't engage in market research themselves, during this development phase, they might work to translate concepts like customer needs into tangible product specifications. So you need to take the customer's needs from your abstract concepts and translate them to specifications that are tangible, that you're going to work on. You have to consider the role of the product, technical feasibility, time to market, and other external demands. So that's where the concept development comes in. And one of the things that we do when we ideate, we'll generally go to the field and do some research, collect data, and use that data to come up with requirements. And that drives us to one document that we're going to look at today, SRS, Software Requirement Specifications. So what are software requirement specifications? Do we approach them in the right way? But let me just expound on that. It falls under documenting your product professionally, having a professional approach of how you're documenting your stuff. So I'll use a simple analogy. Maybe you're creating an e-commerce platform and you need to go and collect some information in terms of research. At the end of the day, you'll come up with an SRS document, and some of the practices that we use might not be as professional as they should, and therefore we end up not addressing the right issues. So your documents, SRS software requirement documents, should be clear, concise. it should not be big. It should include an introduction, description, detailed requirements, and a glossary of terms so that it's easier for people to read. So remember, this document will be used by both the technical team, that is the development team, and the stakeholders. These are people who might not be tech savvy and they need to understand what you're building. It's a document that takes your idea and bridges it to your development process. That's why it's a very crucial document. I would like us to underline that functional and non-functional requirements. So most of the time, functional requirements, maybe for our analogy today, that is building an e-commerce platform. Of course, you might want, you might have a functional requirement that is, I would like my users to register. That's a requirement. And I would like us to view illustration today here so that we kind of view this in a different approach. So my epic here, or my requirement here, is multi-language support. So for the platform that I am building, I would like to have multi-language support. Remember, functional requirements are what add up to create everything you need to build on your software. Of course, every software might have user login, user management, you might have registration, you might have, if it's an e-commerce, you might have product purchases and all those requirements that you might build. But maybe let's assume you are working on something that you like to add a functionality, a functional requirement like multi-language support. So of course, it has to be backed up by a user story that you recollected during your ideation phase. And a user story will look like this. As a user, I want to select a language from a list so that I can use the platform in my preferred language. There are keywords there in the user story. As a, who is who are you addressing? Like who are you building this for? I want to, what is the functionality? What problem, what functionality would you like to implement for this person? So that, why are you doing that? What are the frustrations that this user might be facing that you would like to address? So you can see clearly in my user story example there, I have like, as a user, I want to select a language from a list so that I can use the platform in my preferred language. And then the acceptance criteria. These are ones that you'll use maybe to judge if your functional requirement is complete. So acceptance criteria 1, when the user selects a language from the dropdown, the entire interface changes. And then acceptance criteria 2, the language setting must persist across sessions. So this is just one functional requirement, but as you can see, it has been backed up by the documentation that we did, or the ideation that we did, that is the user story, and it's tied back to the epic. Ideally, we will actually assign this story some story points. So depending on the weight of the functionality, you might have more story points. That is like 8 story points, so that you can track and say, oh, I built a certain functionality, it has more weight, so I should actually give it a priority. And there are a lot of methodologies that you will go deep into when you are just speaking of the documentation aspect of the SRS. So, of course, we'll touch on that briefly because we have other methodologies to catch up to. This is on concept development. And I just took one example, an SRS. Number 2, after you develop your concept, you have to design and maybe prototype. So yes, you have an idea, it's finalized. Engineers begin the design phase in which they create wireframes, specifications, drawings, models of the product. This phase will include maybe using computer-aided design tools, that is anything that, any design tool that can be used that is a software itself. Tools to develop maybe 2D, 3D models. Remember that it's not only applying to software, it also applies to hardware. Sometimes you need to design models of a hardware that you need to implement. So engineers will generally design and build prototypes. Prototype is like a smaller, not a fully functional version of it, but something that just gives you a glimpse of the idea of how the final product will look like. They are built and tested to validate product before it moves to full scale. So in design and prototyping, most of the time we need to design our softwares. Maybe it's a software perspective, draw your Figma. Sometimes you need to architect it, have architectural drawings, let's say ERDs, and that's where I'll go to next. I'll pick some few examples on visualizing of your system. This is very important even before you get to the actual engineering. So visual aids like diagrams will provide high level, easy to understand representation of the system architecture and functionality. I'll just pick two for the day: ERD and sequential diagram, entity relationship diagrams. So of course, maybe your software or your system might have a backend, and the backend will use a database, and the database will have some tables in it. So you need to like have an ERD to visualize how your database would look like. And then number two, sequential diagram. Some processes like sign up, some processes follow a certain sequence. You need to visualize those processes so that as you implement them, you don't mess up. So ideally, a sequential diagram would look like this diagram here. It's a type of unified modeling language that will illustrate how there'll be a time aspect, some constraints there in time, and in what order. So there'll be some ordering in which the user interacts with objects and how the system responds. So if I put it simply, it shows a sequence of interactions between the user system and its elements needed to complete the task. So for example, for a sequential diagram, maybe for login, sign up, or a process, let's say add to cart. In your e-commerce, you have an add to cart process. You might have a sequence, and you will see up there at the topmost row, you'll have some objects or the entities that the user is interacting with. And as you go down, you will see that the arrows back and forth, and time is passes. The way as you move down, time is passing. As you move across or horizontally, some different objects are interacted with. And that's how a sequential diagram would look like. Even someone who is not tech savvy will read this diagram and understand, because if sometimes you look at your code, it won't really make sense as code, but as a visualization of a diagram, everything starts to make sense. And maybe something that we all know about, that is the ERD. Any database you have, especially for, let's say, in our e-commerce analogy, you'll need a database for users, a database for products, a database for orders, or bookings. You might need another one for purchases. A lot of tables might be needed for your system, depending on the functional requirements you have. Remember, all these decisions are affected by your SRS or the requirements that you're trying to address. And ERD is very important, especially for the backend development teams. You'll have relationships. It's entity relationship diagram. So you'll show a user has a shop, or a user has purchases, or products belong to a certain shop. If you're building an e-commerce, for example, that will be very important. So for the two diagrams, those are examples that I picked for our number two, that is design and prototyping. For prototyping itself, you might need to do wireframes, high or low fidelity, to kind of know how does this work. Even as there are levels of prototypes. Some will be very detailed, some will be just general. And then number three, this is the actual implementation, materials and manufacturing processes. So remember, this applies all across, even in hardware products, any product. And sometimes you need to choose. If I'm building, what tools am I using? I'm building a web application. I need to select maybe a framework. Is it React? Is it Vue? Is it Angular? If I'm building the backend, will I select Nest? Will I select Laravel? Will I do it with Express? Will I use Spring Boot? You need to choose your materials and your manufacturing processes at this step and actually do it. So as a product, as the product is being designed, and shortly after a prototype, after you have designed, you need to go through your designs and your visualizations and get to choose your tools or your materials that you're going to use. So during this time, engineers will make crucial decisions about selection of processes. Am I going to use this process? Am I going to use this architecture? Am I going to use, what are you really going to use? And you need to factor in cost, scalability, durability, especially scalability. Most of the time, we've found ourselves in situations where we built something and didn't factor in scalability, and it becomes a whole problem in itself. And you need to plan for mass production. That is where the scalability aspect comes in. If it's a software, if it's a hardware prototype, you need to plan for mass production. And then number 4, integration of technologies. So we live in a modern era where we get to integrate a number of technologies to get one final one. You won't like use one technology, especially, let's say, for e-commerce analogy, you might need to log in with that part. Maybe you want to log in with Google or any other thing that you might integrate in your login process. You need to factor in the integration of technologies. Some of the products being engineered will be very sophisticated. They'll need you to work with other engineers from different domains. If it's maybe some medical imaging solutions you're building, they have the software aspect, they have the hardware aspect. So of course, the integration aspect has to be there. Engineers will come together and sit and work together to integrate all these technologies. So the final product might be a piece of software itself, or require separate software product engineering. Ideally, the design and prototyping phase would have included plans for the integration of various technologies to create a cohesive functional product. So this is where number 4 comes in. And then we flow to number 5. Of course, once you've implemented a certain feature, you need to test and quality assurance. And that's where you go back to the slide on we go back to slides on the user story acceptance criteria. So sometimes the acceptance criteria that we earlier discussed in the step 1, these criteria will help you in testing and quality assurance. Like, have I developed it? So the acceptance criteria, you might go to the detail of having business rules, test criteria in this step of the requirement, and it all adds up, because remember, this is a life cycle. Some of the components depend on earlier components, so the acceptance criteria should help you in the testing and quality assurance. And finally, iterative development. So an ideal product engineering workflow, development and testing, is an ongoing process. It's not something that is ending once. It's something that you always have to go back to and iterate until you get what you want. Sometimes iteration will be influenced by external factors, like you did talk to the users, they didn't like a certain feature, you need to go back and iterate that feature. So iterative development is factored in as the last one, because it's something that happens again and again, and iteration is repeating it. So if I get something that I need to do well, I start again from the first step, and then I flow down to implementation until I get the final product. So during the design phase, engineers may have planned for future updates, maintenance. So ongoing testing and monitoring key metrics is crucial to ensuring the product is performing as intended. So iterative development is factored in. So in the next 10 minutes, I would like us to also go through some of the methodologies that we have in modern terms. That's ideally the product engineering life cycle, number 1 to 6. But we have a lot of other methodologies that are used: lean startup, agile methodologies, hybrid. So we'd like to check other methodologies and how you can marry these methodologies to the product engineering life cycle and actually guarantee results, because not all products will be successful when you use an exact life cycle, or we don't want to stick to traditional software development life cycle. Sometimes we have to be flexible. The flexibility aspect has to be factored in. Number 2, we need to also factor in that some products are iterative in terms of their development processes, and they won't use the traditional one. Traditional one will be good if you already know the end product, but in modern times, we use different kind of methodologies. So lean startup, for example, so it's an essential framework for product engineering, and because it provides a scientific and iterative and customer-centric process. And I want to take note of iterative, customer-centric. So you have to always listen to your customers. Remember, we mentioned that you have to factor in your users. You need to remember that product engineering really is focused on usability, and that's where usability comes in. Customer-centric process for managing the extreme uncertainty for building a new product. So instead of a traditional linear process that spends years on planning, maybe a lot of time, some principles can be injected into a cycle to prioritize validated learning and speed. So mostly, I have a table here that I have prepared that will show you the cycles that we've discussed and how I am contrasting them to our lean startup. So mostly the lean startup methodology will focus on build, measure, learn. That is where you build some MVP, take it to the users, and then you measure how the users will interact with it. Will they like it? Will they love it? Would they recommend something? And then you learn from what you have measured, and then you go back and build. That's why it's an iterative process to begin with. So maybe for concept and ideation phase, for lean startup, you'll develop a testable hypothesis. And then the goal will be, instead of detailed business plan, the team will define assumptions about value. Do customers want it? And growth. How will it spread? Number 2, requirement design. You'll build the minimum viable product. So it's a simplified version of the product with only the features necessary. If it's an e-commerce, you'll basically build it with add to cart, purchase. Those are the major features that you focus on, and maybe leave out other functionalities that example like notifications and other stuff, but focus on the main ones. And then this will skip a lot of time that you will really need to to develop fully functional features. And then from there, once you have your MVP, you will measure the customer response. Ideally, that is going to testing. So in traditional engineering phase, you will like test before launch, or test and launch. So you have your MVP now. That's where you did your requirements design and you implemented your simple version MVP, and then you took it to the customers to measure. And then customer reaction and usage data like conversion rates, engagement, actionable metrics, not vanity metrics. And then from there, you can learn and iterate. So there's some important terms there: pivot or persevere. So sometimes you might take your MVP to the market or to your customers. Maybe you are building an e-commerce for your customers to buy things online, and then you realize, oh, my customers actually want to learn of available products instead. So you might pivot from an e-commerce for selling goods to an e-commerce that is actually advertising ready products. That's where the pivoting aspect comes in. Persevere is if you still feel like, nope, let's just remain on the main focus. That is our e-commerce for selling products. And let's do it in a better way. That's what persevere would generally mean. So you learn from the data to validate or invalidate your hypothesis. Remember, you started by having a theory somewhere, this and this will work. And then that's your idea. It's like a hypothesis, your theoretical assumption. And then you use the learning to iterate on that hypothesis, make small changes and repeat, or you might pivot and use the results you got from the customers to build them another solution. Some products have pivoted. You see, some products you might interact with as maybe a photos application. Maybe it didn't start as a photos application. It started as an application that was meant for sharing files. And then they realized, oh, we can share photos. Oh, people want to see photos. And oh, people want to actually share photos on this. So you pivoted from a file sharing thing to a photos application. That's a very good example of pivoting. And then I'll quickly move to agile methodology. These are methodology that we will normally use to optimize the engineering life cycle. These methodologies actually work with the traditional life cycle to actually make you move faster. So we replace the traditional rigid phases with a continuous, iterative, and flexible flow focused on delivering customer value. So instead of completing each stage fully before moving to the next, Agile will integrate these activities into short repeating cycles. If I'm building an e-commerce, people need to sign up, buy goods online, and get their goods delivered. So instead of having all the functionalities, I will start with sign up. And then I'll make sure we research on sign up, we build it, we test it, and then it works. And then we go back to product. We build the entire product catalog maybe, or product basket until it's complete. And then we keep on iterating until we finish. And it's focused mostly on results, not really on the bureaucracy of the process itself. And this is a table that I've also prepared to show us that. So you'll see like in Agile, you'll continuously refine and prioritize. And then design and architecture, you'll look at the new design. You know, in Agile, you have to focus on change. You need to be very flexible because detailed design and architecture are done just in time for the features being built in the current sprint. So there are sprints that we'll have. A sprint is like a period. We say in 2 weeks, we need to have the sign up done. In the next 2 weeks, the product done there. In the next, by product here, I mean by the product feature done. In the other 2 weeks, we need another feature complete. And those are sprints. And then in development, time-boxed incremental delivery. So you keep on iterating on the same waterfall, but you're focusing on the results mostly. So testing and QA, continuous integration and testing. Testing is integrated throughout the life cycle. And then deployment and release, early and frequent delivery. So you need to deploy, if it's something that was already in production and you have added a new feature, you deploy it. And then you create another new feature, you deploy it. And maintenance and support, continuous improvement, retrospective and evolution. You need to support and maintain whatever you have been engineering. So mostly at your own time, go look the Agile methodology into detail. You'll find some important concepts there. Kanban boards where you have a backlog, what is ongoing, what is already shipped, and the time, and we have Scrum Masters that will be very responsible people in the whole process. So I don't want to go into details of the Agile methodology, but at your own time, you can go and actually look at that. Mostly today, you're focusing on the entire product engineering life cycle. And then prototype. I mentioned this earlier at the second stage, design and prototype. So prototyping is not just a single step that I had earlier mentioned. It's iterative and spans the most critical phases of the product engineering cycle. It ensures that the final software is valuable, usable, and feasible. So it acts as the primary tool for validation and refinement at every point where you assume about the user or the technology, and then based on your assumption, you test. So prototypes can vary in different kind of detail. They can be easy, they can be very detailed, high fidelity and low fidelity. That's what I basically mean. But I just mentioned two methodologies, that is Agile, also mentioned Lean Startup, and of course we have our traditional waterfall models. And product engineering will majorly focus on the product and the life cycle of delivering the product, mostly not really the processes. And sometimes you might want to build a product that won't fit any of the methodologies. So it doesn't fit Agile, it doesn't fit the Lean Startup for build, measure, learn. You want to build something that, or you want to gain the advantages of Agile and still maintain your Lean Startup. So you have, that's why a new approach comes in, hybrid. You combine any of the two approaches, Agile maybe and Lean, to have your own hybrid to fit your product. So a hybrid approach is a blend of different frameworks, tools, techniques that you customize to suit your project, organization, and environment. So, so in terms of hybrid approach, some of the products did fail and let's say traditional life cycles that you started with research, documentation, and then you went to building your designs, and then you implemented, and then you tested, but sometimes it fails. You might need a product that is going to the market as fast as you can, and the time might not be enough, and you might need to combine maybe agile and lean startup, and that's where a hybrid approach comes in. But at the beginning, you need to understand, what product am I building? Am I building it in a modern way? And if I'm engineering my product, what is the best way to do it? And this is all realized at the beginning, during your ideation phase, during your brainstorming. Do you document it in the right way? Do you draw your architectures, or we just rush to the actual development? Even if we are doing the agile methodologies, are we following them right? If it's lean startup, have we built our MVP in terms of in the build stage? Are we measuring customer feedback? Because user-centered design is also focused on the users, and as you're tailoring tech to match our own, we need to understand all this. And after you get the principles right, once you're starting to ship your product, or once you're starting to build a product, your phase or your engineering cycle flows perfectly. And for today, mostly I was really looking forward to covering the product engineering, how to engineer your product, and with those actual steps, you can engineer your product. And for the whole series, we shall be diving deeper and deeper into these concepts. This is a starter one, and we are kind of having a general overview of all this. So we look forward to actually dividing its entire ecosystem into 3 parts: product, the engineering aspect of the product, and the platform. So we have the product, the engineering, and the platform. The platform is what supports the product and the engineering process, and we shall go even deeper into that. With that, thank you for your time. That's the end of my presentation. I will hand it back to Ephraim, just in case there are any other questions. I appreciate your time for joining the call today, and we believe that there is a lot that we can achieve. Thank you.